on Archer 2, and I just want to give you a quick overview of some of the work that's been going on since January. So the first one is a piece of work, and forgive me, I don't know all the details of these. I'm presenting on behalf of the authors, but I thought it might be nice for you to see some of the examples for a bit of inspiration. So the first piece of work that's been happening by a postdoc at the University of Plymouth, Amir, he's been looking at some work using OpenFOAM and the flow of fluid through artificial reefs, principally the reef cube concept. And this is an interesting project using OpenFOAM and using the HEC-WSI resource on Archer 2. And you can see some of the simulation results that he's got there. And this is funded by the R&D Solution Fund at the university, and is also supported by a couple of industry partners there as well. If you're interested in this, then feel free to get in touch with Amir. I realise I haven't put his contact details here, but I'm sure if you email me, I can put you in touch. So another project that's been going on, which is by an MSc student at the University of Plymouth. He's just finished his MSc dissertation in offshore renewable energy engineering. And he's been using, Alexander, he's been using OpenFOAM to do simulations of a wind turbine with a surging motion and looking at how the surging motion of a floating wind turbine might affect the interaction between turbines in an array. And so this is an interesting bit of work that is contributing to the use case that Deborah mentioned earlier, also using OpenFOAM. We then also have a piece of work done by HEC-WSI at Newcastle University, and this is from the geotechnics point of view, looking at the cone penetration testing, which is a common test to look at the geotechnical characteristics of soil for things like anchoring of offshore devices and things like that. So slightly different, using the very different, using the particle finite element method. And there's a nice simulation of some of the results there. And this is also supported by CIMNE in Spain as well. Then we also have another piece of work by a PhD student at the University of Plymouth who's been looking at simulations of surface fluff body surfaces for motion reduction of semi-submersible platforms for floating offshore wind. Ignacio, he is also the HEC, working on the HEC as well. So you may see he's in the audience, or well, he's a co-host, but this is some of the work he's been doing for his PhD, simulations of this flat plate moving in rotational motion, and he's done some experiments there. You can see a picture of that as well for validation purposes, and this is also using OpenFOAM on using the Archer 2 resource. Then the last piece of work, we've been working on a contribution to the International Energy Agency's Offshore Energy Systems Task 10, which is doing some work for verification and validation of numerical models for wave energy converters. Myself and Scott Brown at the University of Plymouth have been working on some simulations looking at the interaction of waves with a fixed sphere, and this particular case has some high quality validation data for comparison. So it's a relatively simple case, but the validation data is a low uncertainty, and so we're participating in that using the HEC-WSI resource as well. And I think that's that for now. I'll just stop sharing. So hopefully that gives you a bit of an idea of some of the projects that have been using the HEC resource. A lot of these are via the core partners of the HEC-WSI, and we have a number of project access applications that are yet to get going, but hopefully, well, by the time we have another annual conference, we should have some examples of people using the HEC resource that have applied through the project access mode. And there is a list that's developing on the website of some very interesting stuff that's happening. So if you've got any questions about this, I'll do my best, but if you have any general questions, please go ahead.
Okay, well, I think it's obviously very clear. So I just wonder whether we can use the raise hand function or the thumbs up function and ask the people on the call to give us an indication whether you think that you will be looking to put in or to access this type of resource in the future. So if you can find it, then there's a hand raised. You can, under the reactions, you can, yeah, there's some thumbs up there as well and some hands raised. That's very good. Yeah, I mean, we certainly felt that this this resource would be a very useful thing for the wave structure interaction community. It's a very strong community and we're trying to address some very challenging problems. But I think also, you know, they're very computationally intensive. And so, you know, that's why it's useful to have this resource. A lot of universities also invest in their own HPC, but the advantage of Archer is that you've got a you know, sort of ramp up in terms of a step change in terms of the amount of resource and the number of jobs you can get through. And the advantage of doing it through a HEC is that you have a lot of support as well. And as you're going to hear in the next presentation, then working through the team at COSEC and STFC on on some improvements to the code. And so part of what we hope to be able to do working together is to get some of those improvements implemented more broadly into some of the code that you're working on as well. Okay, so Juar's got a question there in the chat. Can you explain more about the HPC usage for those examples? Not sure, Ed, their proposals. Well, no, some of them you will be able to, I'm sure. Yeah, go ahead.
Well, not really, but I can have a bit of a guess. I know that so the blade resolve turbine modeling was run using OpenFOAM, I believe, on a single node mostly, but over quite a long duration. In order to get those simulations with sufficient time to look at the wake properly and stuff like that. It was one of this, I believe, to be a bit of a limitation is that you only have 24 hours to run. Well, I think actually you can have 48 hours on a long node, but some of our simulations take a lot longer than that. And throwing more processors processors at it doesn't necessarily solve the problem. So, but you can restart your simulation. So those simulations, I think, were run over a number of days to do them. The things like the sphere, I believe, are relatively quick, probably a single node again. Most of the open foam stuff, I think, was probably on a single node. I think some of Ignacio's, you can tell me I'm wrong in a minute, has used more, and we're investigating LES type modeling in open foam and running with up to 4 nodes, I think. And then is that right? He's nodding.
Yeah, hi. Yeah, you're right. I have used up to 4 nodes and trying different combinations, basically to trying to accelerate the simulation, and always running for 24 hours. But most of the time I need to make it run for longer. So I just basically resubmit the same work. Sure.
Yeah. And I don't know about Amir's work, but I can see he's in the list. If he does, he want? If I'll ask you to unmute Amir, but you don't have to if you don't want to.
Hello. Yes, I used normally between 1 to 4 nodes in each terminal simulation. So some of them were running for long term, and the generated mesh was like a bit big. So sometimes I needed to rerun the case for like resubmitting job for to complete the whole task. Yes, I think that's enough.
Yeah, great, thank you.
Cheers.
And then I don't know about the particle finite element method that HEC-WSI at Newcastle has been doing, I'm afraid. But I can tell you it's not a vast, like it's not like using the entire of Archer 2 or anything like that. It's probably around a similar usage. But we are open to people using significantly more than these examples display. So hopefully that answers the question. Yeah.
Great. And I think those examples also show quite a range of different applications. So, you know, if your application is more on the structure side or more on the fluid side, if it doesn't necessarily include both waves and structures, then, you know, please do also put a case in, put an application in, and as long as you can make a case for how it would support a code that could be used for wave structure interaction or working towards wave structure interaction simulations, then it's all within scope of the HEC.